Alright, so, two vectors. And I'm going to introduce the vector notation here. Let's call the first vector v1, and they have half an arrow on the top of them.
Was this an example?
No, this is sort of a definition, but I'm not calling it a definition. It's a rule. I'll call it a rule. Two vectors, v1 and v2, are equal if and only if they have the same magnitude and direction. There is one thing though. They might not quite look the same. And we gotta bring some of these definitions together to talk about this. Supposing I'm on the Cartesian plane and I have a vector here. And I have a different vector, supposedly, there. Now here's what I'm going to tell you. The direction of this one is the same as the direction of this one. The magnitude of this one, call this distance A, is the same as the magnitude of this one. These are equal vectors. Because with vectors, it doesn't really matter where they start. If they have the same magnitude and direction, they are equal. Even though we've got them on different spots in the plane. Yes?
No.
Oh. And the reason is because with vectors you can, and we're going to talk about this in a moment, with vectors you can pick them up and put them somewhere else. You can always pick up a vector and move it. You can't rotate it anymore, you can't make it any longer or shorter, but you can pick it up and shift it somewhere else without affecting the vector itself, because vectors do not specify where they start. They specify how long they have to be and what rotational angle, and that's it.
Is magnitude theta? Is that what you're putting?
No, magnitude is A. That's the length of the vector. Direction is theta. Theta is the direction.
Okay.
Gotcha. All right, so that's our rule. Another definition then is resultant. This is the sum of two or more vectors. And here's what we'll say. For adding vectors, use the tip to tail method. Because you can pick up vectors and put them wherever you want, you can use this method. Something that you're going to have to be able to recognize visually on the quiz is this method. So if I give you one random vector here, and I give you another random vector there, and I ask you to add these two vectors, the way you do it is you pick up one of them and you put its tail at the tip of the other. Okay? So if I were to pick up this one and put it over here, all of a sudden I get something that looks, if I can sort of draw it the same, like that, and then, it's not clear, and then like that. And their sum is the vector from here to there. This one is the resultant, the sum of the two. You're going to have to be able to identify the resultant of two pictured vectors just like this on the quiz. Let's end that board here.